to our Guru Together program. Nice to meet you again. Hope you are doing well. Today I am going to talk about a geometry lesson. That is the first lesson you are going to learn first circle theorem. Here this is the 27th lesson, chords of a circle. By studying this lesson, you will be able to solve problems by using the theorem that the straight line joining the midpoint of a chord of a circle to the center is perpendicular to the chord, and solve problems by using the theorem that the perpendicular drawn from the center of the circle to a chord bisect the chord. So, this second part you can learn under the second part of this lesson. Here today I am going to talk about the part 1. You have to study, in here you have to study two theorems. There are two theorems in this lesson. Here today I am going to do first theorem. To do that, first of all I am going to show some parts of the circle. Look at this, let's see. In this circle, what is this? Can you say that? This is the radius. This is the radius. Radius is the line which joins the center and the point on the circle. What is this? This is the diameter. This is the diameter. What's this? That is the chord. Chord. So, how do you identify the chord? Let's see. Here, the chord is the line segment joining two points on a circle is defined as the chord. So, what's the diameter? Diameter is also a chord, that is the longest chord. That is the longest chord. Diameter is going through the center of the circle. So, I am going to do now one activity. That activity is in your textbook. I think you are ready to do the activity. You have taken your textbooks and writing books. Okay, now you have to prepare your compass to do this activity and ruler and the pencil. Okay, this activity you can see in your textbook page number 101. So, I am going to do that activity. You have to do with me. First, you have to take your compass and you are going to draw a circle. You are going to construct the circle. The radius is 3 centimeter. So, how do we construct that? You have to take your ruler. You have to take your ruler. Then take your compass and you have to keep the compass on the proper point at the point 0, and you have to expand it until taking 3 centimeter. Now you have prepared your compass, then you have to draw the circle. Let's draw the circle. I am going to draw the circle. Now you should draw the circle. Here I have drawn my circle, the radius 3 centimeter. Then we are going to mark these things. We have to name the center as O. Okay, center is O. And we have to draw a chord AB, which is not a diameter of the circle. Okay, so I have drawn a chord. You know what is the chord? Chord is the line which joins two points on the circle. So I have named it as AB. And third one, mark the midpoint of the chord as C and join OC. So how do we find the midpoint of this chord? How do you find the midpoint of this chord? You can draw a perpendicular bisector, or else you can measure this AB chord and you can find the midpoint of that. Then we have to mark the midpoint of that chord. Then we should join the center and the midpoint here. So, after joining that, we have to measure. We have to measure. What are the things we have to measure? The angle OCB and angle OCA. How do we measure that? Using the protractor. You have to take your protractor and you have to measure the angle OCB and OCA. Let's see. So, what are the magnitudes of those two angles, OCA and OCB? You can see it very clearly. Here, what's the value? 90 degree. You can see it clearly. And OCB is 90 degree and OCA, that is also 90 degree. Here the angle OCB and angle OCA is 90 degree. You can observe it clearly. Then I will take another circle. I will take another circle with another chord. So I have done the same activity to that circle. That means I have joined the center and the midpoint of the chord. So what's happened there? So here also I am going to measure the angles which make by joining the center and the midpoint of the chord and the chord PQ. Here let's measure the angles using the protractor. So we have 90 degree. ORQ angle and ORP angle. So here also you can observe that the straight line joining the midpoint of each chord to the center is perpendicular to the respective chord. So by doing this activity, you can understand the theorem very clearly, easily. That's why I have taken this activity. Okay, now I am going to tell you the theorem. Today you are going to learn the theorem. What's the theorem? Let's see here. The straight line joining the center of the circle to the midpoint of the chord is perpendicular to the chord. Let's read with me again. The straight line joining the center of the circle to the midpoint of the chord is perpendicular to the chord. So I will represent that using a diagram. Look at that diagram. So we should have a chord. So I have named that chord as PQ. And center of this circle is O. I have marked it as O. And the midpoint of that chord is R. Okay. So what do you mean midpoint? Midpoint is the middle point of that line. Okay. Then middle point mean by that point separate the given line two equal parts. PR and RQ equal. So according to this theorem, what's the conclusion? What's that? When we are joining the center and the midpoint of the chord, that line is perpendicular to the chord. That's the thing we have studied from this theorem. Here we can say OR is perpendicular to PQ. So this comes from the theorem. So we can represent using symbolic form. Here look at that OR is perpendicular to PQ. To emphasize that, I am going to do one example. Here look at this example. So, what is the sum? LM is a chord of a circle with center O and radius 10 cm. The midpoint of LM is N. And if LM is 16 cm, find the length of ON. Here I have highlighted center. So, center is O. You can see it in the diagram. And the radius is 10 cm. I will mark in my diagram. Here 10 cm, that's LO. And the midpoint of LM is N. Okay, midpoint of LM is N. Here I will have to mark that. Midpoint of LM is N. So I have marked N as, because by the point N, separate the line LM two equal parts. And LM is 16 cm. LM is 16 cm. So we have to find the length of ON. Let's see how it is finding. So in here, you should understand whether we can apply the theorem today you have learned. So let's see, the center and the midpoint of the chord has already joined. So if you have such a situation, you can apply the theorem. So center and the midpoint of the chord has already joined, no? Then you can say, what you can say, that line is perpendicular to the chord. Here you can say ON is perpendicular to the LM. So that means you can say the angle ONL and ONM, they are 90 degree. They are 90 degree. So then we have to find the length of ON. So we have found that the angle ONL and angle ONM as 90 degree according to the theorem. Here, so I am going to mention that. So here LN and NM is equal. No? So I have marked it in the diagram. Now we are going to do the sum. So LM is half of 16. That's 8 cm. NM also half of that. That's also 8 cm. Then we can apply the theorem. According to the theorem, we can say ON is perpendicular to LM. No? Okay, by using that, how do we do this sum? We have to find the length of ON. We have to find the length. So look at that triangle. So ON is in the triangle. Once ON is the side of the triangle OLN. What is that triangle? It is a right angle triangle. So when you are seen in the right angle triangle, who is remember? Who is remember? What is remember? You can remember the Pythagoras. and you can remember the Pythagoras theorem. So, you will study the Pythagoras theorem in grade 11. So, I have mentioned it here. My Pythagoras theorem is, in a right angle triangle, the area of the square drawn on the hypotenuse is equal to the sum of the areas of the squares drawn on the remaining sides of the triangle, which include the right angle. So, this is the theorem which is in grade 11, okay, but you know the Pythagoras relationship. When you are in grade 9, you have learned that. Here, for this triangle, I have applied that. Here, hypotenuse of this triangle. Hypotenuse is the longer side of the right angle triangle. It is opposite to the right angle. In here, ACB triangle, AC is the hypotenuse. So, AC squared is equal to the sum of the square of other two sides. They are AB squared and BC squared. So, I am going to apply this theorem to get the value of ON, because in the triangle OLN, we know two sides. So, we don't know one side. To find that ON side, I can use the Pythagoras theorem. So, in here, according to this triangle, you can understand what is the hypotenuse. Hypotenuse is opposite to the right angle. You can say that OL is the hypotenuse of this triangle here. So, we can apply the Pythagoras theorem very easily. We can apply because here right angle triangle, no, OL squared equals LN squared plus ON squared. So, we know here LO we know and LN also we know. We should find ON. Let's substitute the values we know. LO is 10 and LN is 8 and ON we don't know that. We are going to find that. 10 squared is 100, 8 squared is 64. Then we have to subject ON. To find ON, we have to subject ON squared. No? First, we have to subject ON squared. Then ON squared is equals 100 minus 64. Then you have 36. ON squared is 36. Then we have to find ON. How do you find ON? We have to get the square root of that. So, ON equals 6. We found that. ON is equals 6. Let's do this example. Look at that diagram, you observe it carefully. What's the thing we have to do here? So, there are several angles. We have to find the magnitude of those angles. What are those? A, X and Y. So, how do we find that? Let's see whether can we apply the theorem today you learned. So, we have to check whether the situation here. So, we can see chords. What are the chords in this diagram? I think you can name the chords. I can see two chords in this diagram. I think you also can see two chords. What are the two chords? BC and AB. But here I am going to use the BC chord. Why? Because I can apply the theorem for that BC chord, because according to the BC chord, I can apply the theorem for this sum. Why? I know the midpoint of BC chord. What's the midpoint of the BC chord? That's D. And the center of the circle. Center of the circle and the midpoint of the chord has already joined. Then we can apply the theorem for this part. According to the theorem, we can say OD is perpendicular to BC. OD is perpendicular to BC. Okay, then we can apply the theorem here also. We know BD is equal to CD. Therefore, we can say OD is perpendicular to BC. Using that, why OD is perpendicular to BC? A straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. So, using that, I can say ODC, the angle ODC, the angle ADC. You look at the diagram, then you can understand what I am saying here. The angle BDA, the angle ODB, they all are equals to 90 degree. So, we can say the value of Y. What's the value of Y? It is also 90. BDA angle or ADB angle. Next, we can find the value of the angle X. How do we find that? How do we find the value of the angle X? By looking at the diagram, you think, how do we find that? So, you can think about the triangle OBA. You can think about the triangle OBA. In the triangle OBA, you can see one angle that is 60 degree that was given. Then, what are the known thing in this triangle? Here, you know, two sides are equals. in the triangle OBA, two sides are equals. What are the equal sides? What are the equal sides? So you can see OA and OB as equals. Why they are equals? Why they are equals? They are radii of this circle. They are radii of this circle. Then here, if you know two sides of a triangle as equal sides, what can you say? What's the conclusion can be taken? If two sides are equals in a triangle, opposite angles are equals. So according to that, we can find the value of x. What's that? You know OAB angle and OBA angle as equal angle. So you know OAB angle is 60 degree, then OBA angle is also 60 degree. That is x. Value of x is 60 degree. We found that. Very easy. Okay, let's do the next one. We have to find the value of the angle A. A is representing BOA angle. So we can take the same triangle that we have taken previously to find the magnitude of the angle x. What's the triangle we have taken? OAB. In that OAB triangle, we know two angles. What's that? X is 60, another angle is also 60. So you can tell the remaining angle must be 60, but you have to do that, okay, by using a theorem. So in this triangle, we know two angles and we have to find the remaining angle. Remaining angle is the angle A. Here we have to find the angle BOA. To find the angle BOA, we use the triangle OAB. So we can consider the interior angles of the triangle OAB. So how do we find that? We have to adapt those interior angles. What are those? OBA and OAB and AOB. So in here we have to substitute the values. OBA, what's the value of OBA? That is 60. And what's the value of OAB? That is also 60. And what's the value of AOB? So we have to find that. We have to find that AOB. So 60 plus 60 makes 120 and we have to take AOB. To take that, we have to remove 120 from the left hand side and we can take AOB. It is 60 degree. AOB means angle A. That is 60 degree. We have found all three angles. Y is 90, X is 60, A is also 60. In here, I can take one conclusion. In here, the triangle OAB. What can you say about the triangle OAB? It must be an equilateral triangle because all three interior angles are 60 degree. So that's extra one. Okay, children? Okay, children. Now I'm going to do another example. Take your textbooks and turn the page 104. I have taken a sum from exercise 27.1. That's the first question. Roman number 6. You can see this diagram in your textbook. So in this diagram, what they ask to do? Find the value of x. So we have to find the value of this x angle. So x angle means y o x, simple x. Okay, here you can see the simple x. So you can see another capital X there. That is the letter used to represent the point. So here we have to find the value of an angle. So simple x is representing to find the value of the angle. To take the value of x, how do we do that? So how do we apply the theorem here? Let's see. You can see two chords in this circle. What are the two chords? PQ and QR. And can you see the midpoints of them? Yes, in this diagram they mark that. What's that? X, the capital X as the midpoint of the chord PQ. And Y is the midpoint of the chord QR. Okay, because by looking at the diagram we can understand that X and Y are the midpoints of the chord PQ and QR. Midpoint and the center of this circle is O. These two midpoints and the center has already joined. So what can you say about those two lines? So here XO line and PQ line. XO line is perpendicular to the PQ because of the theorem. So let's see that how do we do that. Here in here I have taken PX and XQ because X is the midpoint of the chord. I explained you earlier. PQ is equals to XQ, that was given, and according to that I can say OX is perpendicular to PQ. Why? Because of the theorem. The straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. Okay, then take another one here. So I have marked it in my diagram. So then I will move to the next part, next chord, that's QR chord. In the QR chord also I can see YR is equals to YQ. YR is equals to YQ. Y is the midpoint of the chord QR. Then we can say OY is perpendicular to QR. OY is perpendicular to QR. Okay, then OY is perpendicular to QR mean OYQ angle is equals to 90 degree. OYR angle is equals to 90 degree. So we can mark it. We can mark it. Okay, now you can see a clear diagram in here. So in my screen you can see that we have to find the value of the simple letter x, the angle XOY. So to find that we have completed some part. Then by looking at that you can understand how do we find the value of x, because we have complete little bit it. Let's see how do we find that. So I am going to consider the quadrilateral OXQY. Look at that quadrilateral. You think that quadrilateral OXQY. By looking at that, you can understand how do we find the angle x. Angle x means simple letter x. Here. So I have separated it. Look at that diagram. We know 3 angles of this quadrilateral. We know 3 angles of this quadrilateral. So we have to find one remaining angle. What's that? X. So you know the sum of the interior angles of a quadrilateral. What is the sum of the interior angles of a quadrilateral? It is equals to 360. It is equals to 360. When you are taking the sum of these 4 angles, we can equals to 360. The reason is sum of the interior angles of a quadrilateral is 360. Then we know 3 angles of that, 90, 90, 60 and x. X is the remaining thing. We have to find x. When adding 90, 90 and 60, it's make 240 degree and we can find x. We have to subject x. X is equals 120 degree. X is equals 120. So we found that. We found that. Then we have to move another example. We have to move another example. Look at this. This example also I have taken from your textbook. Hurry up, turn the page 104. Let's find the third question. Let's find the third question. Hurry up, children. Okay, read it. AB and BC are 2 chords of the circle with the center O which are perpendicular to each other. AB is 12 cm and BC is 8 cm. The midpoints of AB and BC are X and Y respectively. Find the perimeter of the quadrilateral OXBY. So I think you have read the sum and you understood that. Then we try to do, we have to find the perimeter of the quadrilateral OXBY. Let's try to do that. So I have taken the diagram. Here I have marked the given thing. Data. I have marked the data in my diagram. Okay, AB chord is 12 cm. BC chord is 8 cm. AB is 12 cm. BC is 8 cm. What are the X and Y? X and Y are the midpoints of the chords AB and BC. Let's see that. Here we are going to find the perimeter of the quadrilateral OXBY. To do that, we can consider the theorem. So, let's see how can we apply the theorem here. Here X is the midpoint of the chord AB and center of this circle is O. The center of the circle and midpoint of the chord has already joined. So, what can you say about that? The line OX and line AB, what can you say about that? They are perpendicular. Why they are perpendicular? Because when you are drawing a line from the center to the midpoint of the chord, that line is perpendicular to the chord according to the theorem. So, here we can see such a situation. Midpoint of the chord and the center has already joined. So, I have considered the AB chord. Here we can say OX is perpendicular to AB according to the theorem. Here, let's see the theorem. A straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. I said to you. So, here we found that. Then considering that, we can get the angle OXA and angle OXB, because the OX is perpendicular to the AB chord. No? Using that we can get the angle OXB and angle OXA. They are 90 degree. Perpendicular means making 90 degree angle. So we found OXA and OXB angles as 90 degree. So I mark it here. At the same time I have marked the AX and XB. You have to look at the diagram, children. Okay, you have to look at the diagram. So AX and XB as the AX is 6 centimeter and XB is 6 centimeter, because they are X is the midpoint of the chord AB. You know, then you have to understand AX and XB as 6 centimeter and 6 centimeter, and here we have to mark the angle OXB as 90 degree. So you know, you should understand OXA angle is also 90 degree, but here I mark the angle that I want. Okay, here the angle is also, the adjacent angle OXA is also 90 degree. It's already happening. Here I mark only one part of that, OXB, that is also 90, because for my sum, to do the sum, I use that angle. Then I am going to find another angle. I will move to the other part, chord BC. In the chord BC, Y is the midpoint of that chord. No? So BY and YC are equals. Y is the midpoint of the chord BC. Then midpoint of the chord BC and the center has already joined. What can you say about that? So the OY line is perpendicular to the BC chord. Why it's happening? A straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. In there also same thing is happening. A line drawn from the center to the midpoint of the chord, it should be perpendicular to the chord. Using that theorem, we can say OYB, the angle OYB and the angle OIC, they are equals to 90 degree. So here also I will mark one angle, that is angle OYB, that is also 90 degree. Okay, now look at the diagram here. So what can you say about this OXBY? We have found 3 interior angles of this quadrilateral. We have found 3 interior angles. Then we should find another angle, otherwise we can't understand what is this quadrilateral. OXBY is a quadrilateral. We have to consider that. OXBY is a quadrilateral. Quadrilateral is the polygon having 4 sides, but we can name this is a special quadrilateral. So how do we recognize that? Here we have to find the perimeter of this quadrilateral OXBY. You may think now we have already finished and we can find OY is 6 centimeter and OX is 4 centimeter like that. No, we can't do like that. Here we should recognize clearly what is this quadrilateral is. OXBY is a rectangle or square only. We can consider opposite sides as equals. Here if this is a rectangle only, we can consider opposite sides are equals. If it is a square, all sides are equals. Here first we recognize this, first we identify this quadrilateral as a rectangle. Let's see how do we find that. Here we have to find the other angle of this quadrilateral OXBY. So we can consider the interior angles of a quadrilateral. So when we are taking the interior angles of the quadrilateral, we can find, it's clear, the angle XOY is equals to 90 degree, because we have to substitute the values of other angles, and automatically we can say that XOY angle is equals to 90 degree. So we found all 4 angles of this, each angle is 90 degree. Then we understand this OXBY is a rectangle or a square. This OXBY quadrilateral is a rectangle or a square, but we should recognize this quadrilateral is a rectangle. Why? Why? Because the adjacent sides are different. In a square, all sides are equals. No? A rectangle, adjacent sides are different. So we should recognize this quadrilateral is a rectangle. Okay. Here then we identify this OXBY as a rectangle. Then how do we take the perimeter of that? By adding the length of all 4 sides. But here we know 2 sides now. Here we know length of 2 sides. That's why we identify this quadrilateral as a rectangle. In a rectangle, opposite sides are equals. Opposite sides are equals. So by using that fact, we can find the perimeter of this quadrilateral OXBY very easily. Okay. Then to find the perimeter of the OXBY, quadrilateral, we can find that easily here. That is a rectangle, no? We can find the perimeter xb plus by plus oy plus ox. We have to add all those measurements. xb is 6 centimeter, by is 4 centimeter, oy, what's oy? Oy is opposite to the xb, that is 6 centimeter. Ox is opposite side of by, so that is 4 centimeter. Then we can find the perimeter of the rectangle. It is 20 centimeter. What do you think, children? That's very easy. We have applied the theorem very easily, very clear. If you, I think you understood the sum easily. Okay, then I am going to do the formal proof of this theorem. I am going to do the formal proof. So you should practice the formal proof of this theorem. So now I am going to do that. Here, how do we do the formal proof of this theorem? Look at that first. Look at this diagram. In this diagram, we are going to prove the theorem that you have learned. Okay. Here, first of all, here in the beginning of the lesson, we have done one activity. Practically, we have proven the theorem. Here, we are going to do the formal proof of the theorem. This is the one theorem we have to practice the formal proof for our exam. Okay, how do we do the formal proof? First, we have to write the data. What are the data here? AB is a chord of a circle with center O. The midpoint of AB is X. The midpoint of AB chord is X. First, we have to write the data, and there is a procedure to prove. There is a procedure. Under the procedure, first we must write data. Data means given thing. So, what are the given thing here? O is the center and AB is the chord and X is the midpoint of the AB chord. We should write that. Then, we should write the thing we are going to prove. We are going to prove the theorem, no? So, according to the diagram, we must write that. So, in the diagram, the midpoint of the chord is X and the center is O, and the midpoint of the chord and the center has already joined, and we should say OX line is perpendicular to AB according to the diagram. Then, we can join OA and OB, because under the, we have to do one construction here. The construction, to prove this, we should do a construction. The construction is we should join the point O and A and O and B. Okay. After the construction, we can move to the proof. So, we can prove now. So, to prove that, we have to join that under the construction, we have to join it now. Then, we are going to prove that. Okay, now we are going to prove. We are going to prove the theorem. To prove the theorem, I have done one construction. Using the construction, we can do it very clearly, very easily. Here, we have to consider the congruent triangle. You can see two triangles in this diagram. What are the two triangles in this diagram? OAX and OBX. They are OAX and OBX. So, we can congruent these two triangles. Under the proof, we will congruent these two triangles. So, by using the congruency, we can prove this theorem very easily. So, what are the equal properties? When we are congruenting two triangles, we have to consider the equal properties of equal elements of two triangles. So, in these triangles, OAX and OBX, you have to consider the equal elements. What are the equal elements can be seen here? I can see one thing here. What's that? AX is equals to XB, because X is the midpoint of the chord. What else you can see, children? So, I think you can say, I can hear you. Here OX is the common side. OX is the common side. You can see that. Okay. So, we have done one construction now. Using the construction, you can see another one. What's that? You can say OA and OB are equal. Why? They are radii of this circle. Using these three elements, we can congruent these two triangles. Under the congruency part, we learned 4 cases now. Here I use the side case. So, we have remained another 3 cases. I know you know those, all the cases. You like to do the congruency. I know that. Here I use the case SSS, side. Let's see that how it is coming. In the triangle OXA and triangle OXB, OA equals to OB because of radii. AX equals to XB. X is the midpoint and OX is equals to OX, that is common. So, reason is common. We are always writing the reasons. When we are doing the proving sums, we have to write the reasons. That's compulsory. After considering these three elements, we can say the triangle OXA and the triangle OXB are congruent to each other under the case of SSS. So, if two triangles are congruent, what's happened? Remaining corresponding elements are equals. In these two triangles, I will select one pair. I need that to prove this theorem. So, I will select two angles. What are the angles? OXA and OXB. These two angles are equals. Why? What's the reason? What's the reason for that? Here, when you are taking the two equal angles, considering the remaining corresponding elements of congruent triangles, here you can say OXA equals OXB, no? Then we have to consider these two angles. Where are they? Where are they? They are on the straight line AXB. Okay, here I have done it. In the triangle OXA and OXB, two sides OA and OB, they are ready. OA equals to OB, and that means AO equals to BO. It's also okay. And AX equals to XB. X is the midpoint of the chord AB, that also given. And OX equals to OX because of the common side. Then we can say the triangle OXA and the triangle OXB are congruent under the case of SSS. Okay. Then using the remaining corresponding elements of congruent triangles, we can say the angle OXA and the angle OXB are equals. The angle OXA and the angle OXB are equal angles. Why? They are the remaining corresponding elements of congruent triangles. Using that, here this OXA angle and OXB angles are on a straight line. No? When taking those two angles, they are adjacent angles on the straight line AXB. Sum of the adjacent angles of a straight line should be equals to 180 supplementary adjacent angles. I think you know that. I know here I think you know when taking the adjacent angles on the straight line, they are supplementary angles. They are equals to sum of those two angles equals to 180. Here I have taken that. But here we know OX and OXB are equals angle. No? Then I can consider 2 OXA because OXA and OXB are equals. Then I can consider they are as twice of OXA. Then OXA is equals to 90 degree. OXA is equals to 90. What can you say about OXB? OXB is also 90 degree. Then we can say OX is perpendicular to AB. OX is perpendicular to AB. That's the theorem. We have proven the theorem. So, that's the thing we have to prove. Okay. By using that, I am going to do one example. That is that example goes with your textbook. I have taken it from your textbook. You can turn the page number 107. Okay. Then exercise 27.2. Fifth question. Take this sum. You have to observe the diagram and you understand it clearly what is the thing we have to do here. AB and CD are two chords of a circle. Let's see, while we are reading, look at the diagram. AB and CD are two chords of a circle with the center O. The midpoints of AB and CD are P and Q. When we are reading, you look at the diagram. Midpoints of AB and CD are P and Q. The chords AB and CD produce meet at M. They produce until meeting at the point M. Show that POQ and the PMQ angles as supplementary angles. So, what do you mean supplementary angles? Supplementary, complementary, you have learned them. Supplementary means when adding those two angles making 180. Complementary, so I am going to tell that. Complementary means when we are adding angles, they make 90 degrees. So here we are going to show angle POQ and the angle PMQ makes 90 degree. They are supplementary angle. So let's see what are the angles in diagram. You can see that. Here we are going to show that. First we have to write it, no? OPQ and PMQ are supplementary angles. So I have written it POQ, the angle POQ plus angle PMQ equals to 180 degree. So that's how we are showing them as supplementary. So we have to show those sum of those two angles equals to 180. So look at the diagram, you can see that here. So we are going to show those two angles equals to 180. So by looking at the diagram, you get an idea how do we show that. So where are those two angles are in this diagram. So then using you have to think about that. So by looking at the diagram, you can understand. So to show these two angles, sum of these two angles equals to 180. Okay. Then we are going to do the sum. We are going to prove that. To prove that, first we understand, we have to think about the theorem today we have learned, because here we can see the chords. We can see two chords. What are those? A, B and DC. So P and Q are the midpoints of those two chords. Then midpoints of the chords and the center of the circle already join. In that situation, we can apply the theorem. So here we can use the theorem AP is equals to PB. Because of that, P is the midpoint of the chord AB, and we can see the line join the center and the midpoint of the chord. Then we can say OP is perpendicular to AB. Why? Why it is that? A straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. Okay, then we can put the 90 degree, because if they are perpendicular, we know OPB angle and OPA angles equals to 90 degrees. So we can mark that angle in the diagram. So when we are marking those data in the diagram, we can understand the sum very easily. So when we are finding the things, while we are finding, we get some solutions. So if we can mark those solution in the diagram, so we can understand, we can do the sum very easily. Here then I will take other chord, that is the DC chord. When taking the DC chord, Q is the midpoint of that chord, no? And midpoint of the chord and center O has already joined. Then we can apply the theorem, that is OQ is perpendicular to DC. Then we can say, according to theorem, we can say that. What's the theorem? Again, I'll say that a straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. Using that, we can say the angle OQC and the angle OQD, they are 90 degree. They are 90 degree. Okay. Then we have found two angles in this. In this mean, what is that actually? So you can see that here OP is perpendicular to AB. So I am going to say some important thing here. OP is perpendicular to AB, no? Because of that, we can say here, I mark those angles. So I am going to tell it here. So same thing, OPAC equals to OPB equals to 90. So I am writing that here. And here OPB. So OPB, I have written OPB. You look at the diagram. OPB and OPM, both are same. Both are same. Because A, P, B, M, they are on the same straight line. We have produced the AB chord until meeting the point M. We have produced AB chord. So that we can say the points which are on the AB, the A, P, B, M, they are on the same straight line. So we can say, instead of OPB, we can say OPM. Same thing for the other side, OQ perpendicular to DC mean O cubes D and O cube C equals to 90 degree. No? Instead of O cube C, you can put OQM. Instead of OQC, you can put OQM. Why? D, Q, C, M are the points on the same straight line. The DC chord has already produced until meeting the point M. Then using these, we can get OQM and OPM. They are equal to 90 degree. So here I am going to show something. By using these angles, I am going to show you something. Here, look at this. You have to consider the quadrilateral OP MQ. OPMQ. Look at that quadrilateral. So quadrilateral means the polygon having 4 sides. So look at that quadrilateral OPMQ. In that quadrilateral, we have found 2 angles. And remaining 2 angles. What are the remaining angles? Here we can see the 2 angles we have found, OQM and OPM. So the remaining angles, we have to find the remaining angles. So these are the angles we have to show. Sum of these two angles should be equal to 180. That's the thing we have to prove. So in our quadrilateral OPMQ, the remaining angles we have to find those 2 angles. Then how do we find that? How do we apply? How do we get that value? Okay, we have to consider the interior angles of this quadrilateral OPMQ. What are the angles? OQM, OPM, POQ and PMQ. Sum of these 4 angles equals to 360. Why? The interior angles of a quadrilateral is equals to 360. Then we have to add up those 4 angles and we can get the value. Here 90 degree. OQM is 90 degree. We found that early. And OPM that is also 90 degree. So POQ, we don't know that. PMQ, we don't know that. The sum of all 4 angles equals to 360. Then we can get the sum of these 2 angles equals, that means POQ and PMQ. We can get that equals to 180. Okay, POQ and PMQ equals to 180. So we have proven that. We have proven the given thing. Okay, like that we have to do lot of sums. So you have lot of sums in your textbook. We can do all the sums and we can practice this theorem very well. I think you can practice that. So then after doing those sums in your textbook, you can move to the activity book, other activity books to do the sum. Then by repeating the sums, by repeating the same sum several times, you can practice the theorem very well. Okay, so today I am going to wind up my lesson now. Before winding up the lesson, I am revising what we have learned. What's the theorem today we have learned? So the theorem is, here you can see the theorem, the straight line joining the center of the circle to the midpoint of the chord is perpendicular to the chord. So PQ is the chord of the circle with the center O and R is the midpoint of the chord PQ. If R is the midpoint of the chord PQ, we can say PR and RQ as equals. Then we can join center and the midpoint of the chord. Then you can say OR is perpendicular to PQ. That means ORP and ORQ equals to 90 degree. Okay. So this is the theorem we have learned today. So this is my chords of the circle. Under the chords, first part of the chord of the circle, we have learned the theorem, and under the part 2 we can learn converse of the theorem. That is also very easy part. Okay, I think you can practice these sums. So I will give homework to do you. Here, what are the homework I am going to do? I'm giving. You have to do the exercise 27.1 and 27.2. I think you will do them, and you can do other extra sums from other activity books. I hope you will do these exercises and you can collect more and more sums from other extra books. You have to practice well and you will be expert from this theorem. So I will meet you with the part 2 of the chords of the circle. Okay, nice to meet you children. I will meet you soon with the part 2 of the chord of the circle. Have a nice day.